Hey guys, welcome back. It's been a little while since the last video, and I got a bit of a cold and kind of lost my voice for a bit. And I apologize in advance for any sneezing or coughing in this video. Let's see if I can manage. Anyway, welcome back for some more game development. What you're looking at here is a level that I've been working on for about maybe a little less than a week. This level is one that I imagine being part of the actual single-player campaign in Means. It's a level that I tentatively call the Refinery, and it is very much a work in progress. I'm sort of trying to hone my level design skills, and I designed this level actually quite a bit differently than I have done in the past for Project Slide. Let's have a quick look at the thing here in the editor. We can maybe even turn off the fog for a bit. Fog off. So you can see there's a lot of stuff here that's just basically plain unshaped, unsculpted terrain, and these mountains in the distance look very, very boring and straight. At least if we turn on the pre-tessellated terrain, you can see that it's very much just like a straight edge of the thing. But this part of the level is slowly coming together quite nicely, I feel. And the way I've done this time around is that I've used my my Blender Sync quick mesh system to model these blockout cliffs and other things. So basically, if you don't know what I mean, I have a system where you can click Edit in Blender here in the editor. If you switch to Blender, you get a nice small slice of the level that you can open up like this, and you can make changes to this object shown in blue, which is the Blender Sync target. So it's the object that we're actively modifying, and you get the surrounding objects along with it if you want, so that you can actually properly model to scale. And you can then just cancel the edit, and all the data is sent back and forth between the editor and Blender automatically. Here's an example of a smaller mesh that I model like this. And this is very cool. Previously in Project Slide, I've modeled all the cliffs as sort of a set, and then I try to make them fit in the level, placing and scaling and rotating them to make it look like it like they fit together and they form a sort of cliff. That can be a pretty good way of doing it, and especially if you have really good cliff models, that can look really good. But with this, you can actually model these things to follow the terrain and whatever you need very precisely. I think this is something that only really works well if you go for a fairly low poly aesthetic, something that I am doing with Means. And yeah, I think this is starting to look quite nice. Obviously, this is still very, very early and untextured and so on. But I think it shows some promise already, and it's quite fun to work this way. And I'm not going to go super deep into what this level is about. I think maybe I will at some point, but I I prefer to leave some of the mystery for when you actually get to play this later on. But suffice to say, we have this monorail here, which I thought would be the subject of today's video. Maybe I'll actually even split this up into a couple of videos, because it might be a little bit of work. So, what are we looking at? We have this this monorail station here, essentially. This is not, we don't have cliff models here yet. I can say as much that you're supposed to be driving up this ramp here, and there's this blockade that you need to somehow clear or overcome. And here you have a monorail station, the end of the monorail. This is obviously very unmodeled, undetailed, yet you can still see that you can actually see the end of the rail here, etc., etc. But this thing is supposed to bring you into this other facility, shall we say. Currently you can just drive in here because there's just like, I have a few pieces here to denote the fence or the edge or whatever. And here you have the other station. But due to some circumstances beyond your control, you will need to actually use this monorail at some point. And I was thinking this could be a kind of an interesting thing to try to get working today. And for this, I have already set up a monorail car. Or shall we say, the blockout version of a monorail car. If we could connect here to the game, we can get a preview. And we can go to Blueprint and to Refinery Blueprints. So here we have a monorail car. Actually, let's do this, and I can just detach this window. You can get a better look. So these yellow boxes here, they can toggle on and off with this. These are the physics blockers. So you can see that it's not super accurate currently, but it is accurate enough to actually carry things in the car. So these bottom things aren't, they don't have colliders yet. But we have colliders around the edge, and we have a floor. We have a slightly slanted floor because this thing has this slight ramp here. This actual ramp, or this door or side or whatever you want to call it, doesn't have a blocker yet. That's something that I will need to put in at some point. But it is just there as sort of a detail right now. And so this object, which is what we're going to try in this video to, or shall we say this or the next, but let's start in this one. I'm going to try to make it run along this monorail track here in such a way that it can actually carry dynamic objects, and you can even drive like a car into it and then activate it. So quite a bit of complexity actually, and we'll see how all of this turns out. But what we currently have here in this object is a dynamic body transform component. So this is a dynamic body. It is, however, set to be kinematic. So this checkbox right here. If you don't know what kinematic is, it basically means that in the physics engine, this thing doesn't get simulated, doesn't get moved around by forces in the same way as other dynamic objects. It, however, does affect other objects. Anyway, this kinematic flag, if we turn this off and we go into the game, let's go in the very beginning where we have our core. We can add one of these monorail cars here. And let's see what happens. So now the kinematic flag is turned off, right? So now this is essentially a traditional dynamic object. So now we can just push it around like this. We should be able to just drive through that side ramp there, because it doesn't have a blocker, like a physics shape attached to it. Oh, and now we got stuck. But yes, now this is a classical dynamic object, if you will. And so now if we go back and we turn this kinematic flag on again, I wonder if we can actually drive into that now? The angle is quite high, but you will see what I mean. Now if we angle it a little bit, you can see that it actually stays in the air. It's still a dynamic object, and that has some makes it behave in some specific ways in the physics engine, but it doesn't get affected by forces. You can't push it around like you can any normal dynamic object. It can, however, be moved around with code, and it should also behave quite nicely with other dynamics, truly dynamic or non-kinematic dynamic objects on top of it or inside of it. At least that's what I'm hoping. So we will need to somehow make this thing follow the track over here. We will need to make it start here, follow the track, and stop there, and we need to make that somehow controllable from the game. So how do we do all of this? Well, first of all, let's have a quick look at this actual track mesh. You can see it's a pretty huge mesh. It's all in one piece currently. Not necessarily something that will be the case forever. These pillars, these supports, are just objects, primitive objects that I've put in the editor. So they're not part of this mesh currently, but the actual track is. And now we can. You'll notice that it takes quite a while for it to actually export the surrounding objects. Now that we open this mesh in Blender, it takes essentially all of the other objects here in the surroundings and packages them together. Let's see if we can. Blender is still opening it. There we go. So here we have the actual mesh, and apparently I haven't set my surrounding object bounds correctly because it kind of extrudes from it, but it's close enough. So what are we looking at here? Well, this is something that is actually quite new to me. So I did this using geometry nodes actually. So what I did was I modeled this small piece of the track, and I have a spline here, or a curve, a NURBS path in Blender, which I can then edit to make this actual track. So if we just take one of these points here like this, we can move it around, and the track actually follows along with it. You can see the pillars obviously don't, because Blender has no idea about those currently. But that's how this track is modeled, and that's kind of an interesting thing. I'm not sure my geometry node is the most optimized. We can have a quick look at it here if you're interested in geometry nodes. I kind of am, but I'm very much a beginner. Anyway, we take this path, we resample it, and we instance on the points. And we actually have quite a few of these, 112 currently, of these small track pieces. Then we make sure that they are rotated correctly, and we realize them, as it is called. And the output of this is a mesh that looks like this. I have to do some welding here You can see if we actually turn the welding off, you can see the parts here where one of these instances ends and the next begins, and this welding operator makes it sort of weld together the vertices that are close enough so that you don't get this kind of behavior here. So that's cool. So we have a path here, and we could perhaps make our car follow the path. The problem is that I don't really have an easy way to export this path as a path into the Basis engine currently. So that doesn't really work, but we should be able to just create a path directly in the editor that follows this closely enough, I think. So let's cancel this edit and go back here. So, right. I have something here in Basis, which we can use to create an animation, a so-called transform animation, and I think that is what we will probably use to create this thing. So let's go to refinery to lift station. That's the monorail. I'm thinking I might have several of them here. And create a new folder for us, and let's call this track. We actually have already a track folder here. What do we have? That's just a quick mesh. Okay, maybe we don't need a folder. Actually, we just go in here, and we start by creating a curve path. So a curve path is something that you can toggle this off, and I'll show you what I mean. So you can have an editor waypoint like this. If we click here, the editor waypoint is placed directly onto the ground. That's not really what I want. I want it to be slightly above ground. So let's make it spawn the point 5 or half a meter, half a world unit above the ground. And now if we start putting these points onto the thing, you can see that this curve path is generated, and it follows through all of these things. So that's pretty nice. So now we need some way to actually start here and then follow this thing to the end. And then you can imagine us clicking and creating the same path which runs along this mesh here. And there's something called a path animation which we can use for this. Let's make the track the active parent, and we create a path animation that makes the path animation appear as a child of the track. And path animation wants to know quite a few things. How long is the animation supposed to last? 10 seconds. It's probably too short, but let's leave it like that for now. Animation frame rate is 60, that's fine. Position path. So this is now when we animate a transform. So for example, something like the monorail car. We will essentially be animating its position. I mean, this is not the monorail car, but you can imagine it is. We will be animating its position like this. It will follow along path, and we will be animating its orientation. And so this position path tells us where along the animation is the thing that we're animating supposed to be. Well, that is this path here. So let's take the curve path, copy full path, and paste it in there. And position sample curve. So this is a curve. It's set to smooth normalized. If we open this up, we need to actually make it so that we can always open up the curves with the curve editor. Don't know why I don't have that set, but here we go. Curve editor. You can see that it's just an S curve essentially. So it starts slow, and then it picks up speed, and then it slows down when it ends. And that's probably exactly what we want. So that's fine. Let's leave it as it is. Look at target mode. So we have a few things here that we can set depending on how we want the orientation to be, right? So look at target path. If we have another path with like a look at target, we could use that. We can use position path direction, which means that it essentially follows the tangent or the derivative of this, the direction of this curve, which is probably actually what we want. We can do the same with an offset, so it can like look a little bit ahead, or we can just have it look at some object in the world as it is playing the animation. But let's go with position path direction for now. Transform reference object and fallback up direction object. We don't really need those. They are only if you make some really like tricky animations, especially with regards to like look at objects and how it is supposed to rotate them. But we can click build and then we can click preview. And now we can see that here we are actually now animating something along this line. It looks basically like exactly like we want. So it just follows along this curve. We can make the animation longer. We can make it like 60 and build and preview. So now it starts. Now it takes a whole full minute for it to start, and you can see it's starting very slowly, and then it kind of picks up speed a little bit after a while. And that's fine. You can see it actually. There's a little bit of jumping here. You can see it doesn't really stay on the curve all that well, and we should be able to actually improve that. So we use something called a lookup table for sampling this at equal distance points. Let's make this something like lookup table, so LUT sample distance 0.5, and make the T step much smaller as well. Something like that, and then we can try to preview this again. And now we should stay on the curve a bit better than before, and you can see that yes, it does indeed do that. Moving at a fixed rate along a curve is kind of tricky if you use Bezier curves like this. You can sample this Bezier curve and you get like the mathematically correct position and direction and everything out of it. But depending on how you have these things set up and the distance between these control points and everything, it might move sort of faster or slower along certain points. That's why we use a lookup table, which essentially like pre-calculates a set of points along this curve. And that's what that sample distance is all about. But this looks pretty good. Z is forward in basis, so it uses a left-handed coordinate system. Y is up, that's a green one. Z is blue, and X is to the right. So that looks essentially exactly like what we want. So we can just take this away. And actually, we can probably just delete those. We can leave that guy there for now. And we take the curve path, make it the active parent, and we simply start to map out the curve along this. So I'm going to put the distance to 0 so that I can just essentially by eye create this path here. And I think if we consider the car, the monorail car is about this big, we can put the first position there, and then we just start to lay this out. You can see that the line sort of disappears a little bit because it kind of intersects with the mesh, but that's fine. We will probably have to adjust the exact position of this and the height and all of that a little bit later. So I don't necessarily need to make all of these points we could perhaps go with fewer, but let's try to make this somewhat heavily tessellated to make sure that we stay on the track. And again, maybe I can actually export this curve from Basis or from Blender at a later point, and then we don't need to do this step at all. Something like this, and then it just ends about there. So again, if we consider the size of the car and the center of the car to be there, we don't want it to fall off the track. And now if we lift all of these guys up just a little bit. Oh, I misclicked there. Let's select all of these guys again, and we'll just lift it up ever so slightly. We should now see that we have a nice contiguous yellow line along this track here. So that's pretty nice. And now, if we still have this guy previewing the old curve. So now if we do build, we can leave it at 1 minute, I think, yeah. And build and preview. So now we can see, I'm going to take the gamepad and we can fly along here with this guy. So that's the transform of our monorail car. That looks pretty good. That looks pretty good. Yeah. And then it should come here, and then it should slow down. And this preview is actually looping, so it will then just essentially disappear when it reaches that point. So, and we are, boom. Yes. Cool. And it begins again. Okay. And then you can, of course, play the animation forwards or backwards or whatever. Adjust it from code if you want to. So you should be able to use this same path and same animation to go the other way if we want to do that. Okay, cool. I think maybe we'll leave it at like this for now. And in the next video, we will start actually writing a component that we can add to this guy. Right, so we can add... Actually, I can take this component, or this waypoint here. The monorail car is actually probably supposed to sit under the track, right? Let's move it there. So we take this first waypoint, and we copy its transform, and we paste it to this guy. So we can see that, right, it hovers a little too high above the thing. So you can bring it down just a little bit, something like that, and then we can do the same thing again. Take the first waypoints transform and paste it onto this guy, and now it looks much better. So I think this is probably the correct height for this. Right, so next time we will we'll write a component for this car here, which will essentially move it along this line, hopefully with a bunch of dynamic objects and vehicles and things in it. And let's try to make it so that you can actually use this as a means of transport. Isn't that fun? Cool. I thank you for your time, and I hope to see you in the next part. Bye.